So consider this given problem statement. So here set A and set B are given as two sets, and this is one expression that is given here. A union B is equal to A intersection B. So in that case, which of the following option is correct? So let us analyze each of the option one by one. So to check this, I will try to take some examples for the analysis of these statements. So like first statement is given, that can we conclude this, that A is equal to empty set. So assume that set B is a singleton set and it contains an element 1 or any integer of your choice, and the set A contains that is set A represents empty set, that means it does not have any element. So from this we can say, if I compute this A union B out of this, if I compute this one, then the result will be empty set, that is pi union B, that is a singleton set, and this releases 1, right? This yields as 1. Now let's compute for A intersection B. So this would be, so if I take the intersection operation, so in that case nothing comes out common, right? So the empty set intersection with singleton set 1, so we get empty set. So from this we can say, that this particular statement, that is A union B is not equal to A intersection B. So this is what the conclusion is for option A. Now next, let's check for option B, that is when B is given as empty set. So we can take similar assumption here as well. That is, for A, we can take singleton set 1, and for B we can assume this to be empty set. So in case of A union B, I just need to exchange this anyways. So if I perform this operation, I'll get 1, and in case of intersection operation, I'll get empty set. So from this again we can say that A union B is not equal to A intersection B. Now let us analyze option C, that is A is not equal to B. So let us observe this. So assume for this one, assume that, let us say that A contains the element 1 2 3 and B contains the element that is 1 comma 2. So from this we can say that A union B will be equal to, that is 1 2 3. And if I take the intersection operation, that would yield 1 and 2. This would yield the elements 1 and 2. Done. Now let us check for option D. So for option D, we can check, that is option D is given as A is equal to B. So for option D, I can write A is equal to B, and the given statement, that is A union B is equal to A intersection B. So this is the given statement. So from this we can conclude that A union A is equal to B intersection B. That is what the inference is of this statement. And from this we can say that A is equal to B. Now this statement might not seem very convenient or very convincing. So for this, we'll perform little detailed analysis on this one. Now consider any element X, and let us say X belongs to the set that is A union B. Assume that the elements X belongs to the set A union B. So in that case we can say that X belongs to A, and this is the logical, and sorry, in case of this, or I have to say, or X belongs to the set B. That is what it means. But it is given, but it is clearly mentioned in the problem statement, that is A union B, is equal to A intersection B. So that means X belongs to A intersection B as well, right? So from this we can say, conclude, from this statement we can conclude that my X belongs to A and B as well. My X belongs to A and the set B as well, right? So that means what we can say, thus every element of set A, every element of set A must also be in set B, also be in set B, and vice versa. So from these statements we can conclude that the set A is definitely equal to set B. So this gives us little more concrete evidence that why A is equal to B. So I hope this problem statement is clear. So for this, option D is the correct option. So for this one, the correct answer is option D. So I hope it is clear. So very interesting problem. So counterexample situation might not work every time. That's why I've taken the formal mathematical proof for this one. Okay.